and welcome to Lesson 4.04, Synthesis and Decomposition Reactions. These are the Common Core standards that we are applying to this lesson. There is quite a bit of previous material that is absolutely required. Are you sufficiently prepared? Again, if you have not mastered 305, 308, and 402, please go back. Some previous vocabulary that we do need is we must understand what a metal is and where metals are found in the periodic table. The metals tend to be on the left side of the periodic table. Remember on the periodic table how it kind of makes a little diagonal line to separate the metals from the nonmetals. Nonmetals are on the right side of the periodic table. The oxide with the IDE ending means the oxygen ion, O with the -2 charge. An ionic compound is any time that you have a metal and a nonmetal. A binary molecule just means that you have two elements. Bi means two. So binary molecule means any molecule that has two elements. That's super important because one of our reactions in the future says that we're going to form a binary molecule. So you must understand what that means. Just means a molecule with two elements. Synthesis reactions involve two or more reactants combining to form one new substance. For an example, if we have A and B, they're going to form together AB. There are 4 different classifications based upon the type of reactants that we have. So 4 different types of synthesis reactions that you must know. We're going to include metals, nonmetals, oxides, and we'll see the last one. What I recommend is when you get to the worksheet for 4.04 and the exam for Module 4 and into Module 5 when you need to know reactions, you need to look at your reactants and then figure out which type of reaction is it. The first type of synthesis reaction is where we have a metal and a nonmetal. Okay, we have a metal, calcium, a nonmetal, chlorine. Notice that it is just a metal and a nonmetal. It's not a compound. That is super important. It is just a metal element and a nonmetal element. And what happens is they come together to form an ionic compound. And so when you see a metal with a nonmetal, what you do is you look at their common charges. They're going to form their ionic compound. So we're going to look at calcium, we're going to look at chlorine. You have to look at that sheet of common charges and then write their correct formula. We see 1 calcium, it's going to take 2 chlorines to neutralize calcium's charge. Therefore I need 1 calcium and I need 2 chlorines. Therefore my correct formula is CaCl2. So when you're doing these type of reactions, you must look at your reactants and determine, is it a metal? Is it a nonmetal? Is it just an element? Is it a compound? So if you see metal and nonmetal, you know to write the common charges for the 2 elements and then combine them into one ionic compound. This is our common charges from our lesson. Please make sure that you have this saved. Printed is best because you are going to be using it for multiple lessons in the future for this semester. The second type of synthesis reaction is if you have 2 nonmetals. So nonmetal plus nonmetal. Again, notice that it's element and element, not compounds. It's just an element by itself and an element by itself. Remember your diatomic elements from lesson 3.06. If you have one of the 7 diatomic elements, you must write it by itself. So oftentimes, oxygen, nitrogen, things like that, when they're by themselves, you'll see it as O2. They are going to form a binary molecule. Basically, since we have nonmetal and nonmetal, remember, nonmetal, nonmetal, covalent bond. This is not ionic, therefore no common charges. For this class, what we can do is you just add the elements together. However many of each you have, you just add them together. Remember, non-metal plus non-metal is a covalent bond. no charges. Do not look up on the periodic table those common charges. We're just going to add the elements to form your product. Now, does that work all the time? Absolutely not. However, for this class, it will. If you were to take chemistry on the college level, you will learn a lot more information about predicting products for this, but that's at the college level. We're not there. So for this class, this will work. Just add your elements and you'll get your final product. The third type of synthesis reaction is when you have a metal oxide with water. Remember, metal oxide, you have that oxygen. We now have a compound. A metal oxide is a compound. Notice here we have a metal. Okay, so we're going to have to look on the periodic table to see where the metals are, and this is oxide. Anytime oxygen forms a bond with something else, we call it oxide. So this is your metal oxide. When you're doing these reactions on the worksheet and the Module 4 exam and the semester exam, you need to be able to look at your reactants and identify them as one of the type of reactions. So when you do this, okay, say I have a compound, this is a metal, this is oxide, of course this is water, and then you'll find it in the list. Oh, look at this, metal oxide with water. And what that forms is a metal hydroxide. Hydroxide is the polyatomic ion from 3.08, and it's the OH negative. When they form, they're going to form one product, and it's going to be the metal hydroxide. My metal was calcium, so I'm going to have calcium, and then I'm going to have hydroxide. Since this is a new ionic compound, remember ionic compound is metal, nonmetal, we have to look at our common charges. We know that calcium has a charge of 2+, hydroxide has a charge of -1. Remember, ionic bonds form in order to neutralize the charges. Therefore, I need 2 hydroxides to balance calcium's charge. And when I add up the total charges, that equals 0. How many I need tells me how many atoms I have, my subscript. Now, many students would write CaOH2. That is not correct. This formula means that I need 2 hydrogens, 1 oxygen, 1 calcium. No, no, no. I really need 2 of the hydroxide groups. Therefore, I must put hydroxide in parentheses with the subscript outside. Again, if you need more work on that, you got to go back to 305 and 308 because that's when you learn how to write the formulas. The fourth type of synthesis reaction is a non-metal oxide with water. Notice here that we have a non-metal, sulfur, with oxygen, oxide. That's a compound. Non-metal oxide compound plus water. What we get is the oxyacid. Basically, you just add them together. Hydrogen stays out front, and then whatever compound this is. All right, let me get you another example. SO2 plus H2O. What would our products be? Well, we recognize this as a non-metal oxide plus water. Therefore, we're going to form an oxyacid. Acid tells me that hydrogen starts the formula. I have 2 of them here. So for this reaction, I'm just going to write H2. And then I'm going to write the chemical here, SO, and I'm going to add the oxygens, SO3, H2, SO3. You can't do that with every reaction in synthesis and decomposition, but for non-metals, you can. Because remember, non-metals form covalent bonds. We don't use ionic charges for that. Remember this and that other slide where we had the covalent bond. You can add the chemicals together. The order is going to be hydrogen, the other nonmetal, oxygen is always last. All together now, these are the 4 types of synthesis reactions that we have. Once again, when you get to the assignment, it might give you S plus O2 or P plus O2, something like that. you need to find it on this list to find out what type is it. Is it a metal oxide, a non-metal oxide? Is it a metal plus a non-metal or a non-metal plus non-metal? And then you're going to predict your products accordingly. It tells you what your product will be. Let's do some practice. We have a total of 4 practice problems. Go ahead and pause this recording. Go back to the lesson if you need to. Rewind this recording if you need to. And give this your best shot. Hit play to resume. For this one, we see N2 plus O2. N2 is a non-metal. O2 is a non-metal. Therefore, I have non-metal plus non-metal. It tells me that non-metal plus non-metal is going to form a binary compound. A binary compound, we basically just add them together. N2O2. Whatever you have on the left, that's going to be on the right. So N2 plus O2 forms N2O2. Again, there are exceptions to this. However, for the scope of this class, that will work. The next example, we have a non-metal oxide. We have water. Remember what we said about non-metal oxides in water? They form oxyacids. So non-metal oxide plus water, we get CO2 plus H2O, arrow forms. And remember our oxyacids, the hydrogen goes first. The oxygen is going to go last, so then our non-metal will be next, C. And then you just add up how many total oxygens you have. I had 2 over here, I have 1 here, therefore I have 3 in my product. And then of course you want to balance, but these two just kind of balance themselves out. Go ahead and pause this recording so you can do these last 2 problems. Here we have a metal and a non-metal. Uh-oh, metal, non-metal, that is an ionic bond. So what we have to do is we have to look at the common charges of the 2 elements. We see sodium has a +1, chlorine has a -1. It only takes one of each element to neutralize the charges to equal 0. Therefore, my product is NaCl. We need to balance. I see that I have 2 chlorines on the left. I need to have 2 chlorines on the right. This now causes me to have 2 sodiums, so I have to change the number for sodium on the left side. So my final correct answer is 2 sodiums plus chlorine gas, Cl2, arrow, 2 sodium chlorides. The 4th and final example, we have a metal, we have an oxide, we have water. What happens when we have a metal oxide plus water? If you said we're going to form the metal hydroxide, you are correct. So what you do is you go back to the metal, we have Mg, and then we have hydroxide, OH. You look at their charges. Magnesium has a +2, hydroxide has a -1. Therefore, I'm going to need 2 hydroxides to balance magnesium's charge. Anytime you have more than 1 polyatomic ion, you put it in parentheses and then put the subscript outside. So my product is going to be MgOH2, and we have to balance. And it is balanced because I have 2 hydrogens, 2 hydrogens, 2 oxygens. I have 2 oxygens and 1 magnesium. Now we are going to do decomposition reactions. Decomposition are, for the most part, synthesis in reverse. Now we're going to have one reactant, which is the easiest thing to identify, which breaks down to form 2 or more products. And that can be the hard part. How does your reactant break apart? of course, there are 5 different classifications depending on the type of reactant that we have. Yes, you do need to know all 5, and I know all of this can be really, I know it's a lot of work, it's a lot to remember, so please make sure that you write all 5 types on one sheet of paper, just like I did for synthesis, how I had that one slide with all 4 types. Print that, write it down with an example, so that way when you get to the assignment, you can take your problem, look on that sheet, try to see which classification it is, and then be able to write your products. For this section, we do see a lot more with the polyatomic ions. You do need to have that list of them. The first decomposition reaction we have is what we call a binary compound. Remember that a binary compound is a compound that has 2 elements. If you have the decomposition of just a standard binary compound, it is going to quote-unquote break apart or decompose into its respective elements. Water decomposes to form hydrogen and oxygen. Don't forget that hydrogen and oxygen are diatomic. Remember your diatomic elements, we learned those in 3.06 in the multiple bonds section. It's H2, N2, O2, F2, Cl2, Br2, and I2. And what that means is when these elements are written by themselves, such as hydrogen and oxygen, they will always have a 2 after it. All the other elements, when they're written by themselves, you just write the chemical symbol. A lot of students would say water breaks down to form hydrogen plus oxygen. However, hydrogen and oxygen are diatomic elements, so we have to put a 2 after it. If you're not a diatomic element, you just write the element symbol. And then, of course, you must balance. The second example on the screen is NaCl. This is a binary compound, 1 reactant, so we know it's decomposition. So it's going to break apart into its respective elements. So it's going to be sodium plus chlorine. Not ions, but just the elements. When you do this, you want to take a quick moment and check to see if you have a diatomic element. And in fact, I do. Chlorine is a diatomic element, therefore I must put a Cl2. Sodium is not a diatomic element, so I just leave it alone, Na. I have 2 chlorines on the right side, I need to have 2 chlorines on the left, and then balance my sodium. The second type of decomposition reaction we see is a metal carbonate. We have to identify this as a metal, and carbonate is the CO3 with a -2 charge polyatomic ion. You must be able to recognize metals and nonmetals and your different polyatomic ions. If you have a formula that has 3 or more different elements, have a polyatomic ion. That is a quick way to know if you have a polyatomic ion. If you have 3 or more different elements, and in this formula I have calcium, I have carbon, I have oxygen. 3 or more different elements, therefore I have a polyatomic ion. You can pull out your sheet to find out which one you have. So here we have metal, we have carbonate, and when you're done with this recording session, you'll be able to look and say, oh look, metal carbonate. So what do I form? I form metal oxide, which means my metal, which is calcium, is going to form a bond with oxide. Metal, nonmetal, they're going to form an ionic bond, therefore we have to look at the charges. Ca2+, oxygen is 2-. I only need 1 of each to be neutral, so it's going to form CaO plus CO2, so you just write it down. The hardest part, I think, is understanding how to write the ionic bond from 305 and 308. Decomposition reaction, type number 3, metal chlorate. Again, we must recognize K as a metal. ClO3 is the chlorate polyatomic ion. When you get to the worksheet and you see this, you look at your reactant and you say, oh, I have 1 reactant, which tells me I'm decomposition. And then of my decomposition, I see I have a metal, I have K, C, L, Cl is 1 element, Oh, so I have 3 different elements. I know I have a polyatomic ion. I pull out my handy dandy table of polyatomic ions. I find that ClO3 is on there, and it is actually the chlorate. So then I look up in my 5 types of decomposition reactions, and I find metal chlorate. It tells me that I'm going to form the metal. Okay, well my metal was K. And then chloride. IDE means just the chloride ion, which is Cl, not the polyatomic ion. Okay, remember, the polyatomic ion was ClO3, and that is chlorate, ATE. Chloride, IDE, is just the single element chlorine with a negative charge. So potassium, we look up on our common charges because we have metal, nonmetal. That's an ionic bond. So it's KCl plus O2. And then, of course, we have to balance. Decomposition type number 4, metal hydroxide. Once again, we look at our reactant. We see that we have one reactant, that's decomposition. Then we have to figure out which type of decomposition this is. So I'm going to look at my reactant, and I'm going to see if I have a metal or nonmetal. And this, OH, I must recognize that as metal hydroxide. And then I find it on my handy dandy sheet that you're going to hopefully write down or print. So metal hydroxide tells me I'm going to make metal. Well, my metal was calcium, so I'm going to write down calcium. It's going to bond with oxygen, so that's oxygen. Calcium is a metal, oxygen is a nonmetal, therefore I look at their common charges. Ca2 plus, O2 minus. It only takes one of each to be neutral. 2 plus, 2 minus equals 0. Therefore, my formula is CaO. I'm going to write that there and then add water. My products are almost given to me, aren't they? And then last step, you want to balance, and this reaction is already balanced. Decomposition, 5th reaction. Oxyacid. Remember, I said at the beginning, decomposition is basically synthesis in reverse. Oxyacid. Remember, an oxyacid is where you're going to have your H, some unknown chemical, sulfur, carbon, it could be a lot of things. So you're going to have 3 elements. Okay, see your hydrogen. You're going to have your mystery element. Okay, it's going to be some nonmetal, sulfur, phosphorus, anything like that. And then you're going to have oxygen. So you're always going to have hydrogen. Your middle element's going to be a nonmetal, and then you're going to have oxygen. You have one reactant. Remember, that's decomposition. When you see that, you're going to form the nonmetal oxide. So we look at our nonmetal. Our nonmetal is sulfur. It's going to form with the oxide. This one can be a little bit harder because you may not know what the subscript of oxygen is. Sulfur and oxygen are both nonmetals. Therefore, it's covalent, no common charges. There's no ions in a covalent bond. Therefore, SO question mark, we're going to form water, so H2O. Now we're going to go back and look and see, okay, we had H2SO4, we formed H2O, so that took care of the hydrogen, and that took care of one of the oxygens, right? So what am I left with? SO3. That's how you find out what your compound is, because they must add up. It's covalent bond. That's the only time you can do this. That is probably the easiest way. So just look at your compound that you started with, H2SO4. We know that it's going to form water. So there's the H2O, and I'm left with SO3. All right, if we had H2SO3, we know we would form water, so that takes care of the 2 hydrogens. One of the oxygens is in water, therefore I'm left with SO2. Again, I cannot stress enough, it's only because this is nonmetal, and it's covalent. Covalent. You must know the difference between covalent and ionic bonds, and all it has to do with covalent is nonmetal, ionic is metal, nonmetal. Ionic uses common charges. All together now. Remember that decomposition has one reactant. It is the only reaction that has one reactant. And then you can find what type of reactant you have, and then this will tell you what you're going to form. We are going to do a couple of practice problems. Go ahead and pause this recording, write down these examples, and see if you can write the product yourself. I strongly recommend when you're doing these problems that you always identify if you have metal or nonmetals, if you have oxygen, if you have polyatomic ions, things like that. So here we see that we have a metal. I see that I have a polyatomic ion, and this is chlorate. Therefore, I'm going to look up on my decomposition because I have one reactant, metal chlorite. And remember that the directions tell me I'm going to form my metal chloride. Then I have to find my common charges. Ca has a 2 plus, chlorine has a -1, therefore I'm going to need 2 chlorines to balance my charge of calcium. So it's CaCl2, and the directions said to write the metal chloride plus oxygen gas, which is O2. And then as a last step, we do need to balance this. I see that I have 6 oxygens on the left. I need 6 oxygens on the right. I have 2 chlorines, 1 calcium. There you go. I'm balanced. All right, example number 2. I have one reactant, therefore I know it's a decomposition reaction. Now I need to identify which of the 5 decomposition reactions this is. I recognize that hydrogen is first. I have carbonate. But remember, because some students get confused by this, they want to call this metal carbonate. But hydrogen's not a metal. And the type of reaction that had carbonate was a metal and carbonate. That's not what this is. Therefore, this is the oxyacid. Remember, if you see hydrogen first, that's acid. So oxyacid breaks apart into water and basically whatever is left. H2CO3. So we had the 2 hydrogens were part of water. One of these oxygens went into water. Therefore, what I have left is CO2. All right, go ahead and pause this recording and do these final 3 problems. Let's go ahead and get started on these. Decomposition practice number 3. We recognize we have one reactant, therefore we know it's decomposition. Sodium is a metal. CO3 is the polyatomic ion carbonate. Therefore I know this is metal carbonate, and in our directions it said that a metal carbonate will decompose to form the metal oxide plus CO2. So I know CO2 is one of the products. Now I have to write the formula for the metal oxide. My metal was sodium, oxide is O, oxygen has a common charge of -2, sodium has a charge of +1, therefore I need 2 sodiums in order to balance my charge for oxygen. Remember, your subscript tells you how many of each element you need. Now I need to balance, and in fact it balanced itself. Number 4, lithium hydroxide. I see this as a metal. OH is of course hydroxide. We look on our list of our 5 decomposition types and we see metal hydroxide as one of the types. And it says a metal hydroxide will decompose to form the metal oxide and water. Therefore I know water will be one of the products. Now I have to write the formula for the metal oxide. My metal was lithium. Oxygen is O. I know oxygen has a common charge of -2, and you probably have memorized that by now, right? Lithium has a charge of +1. I need 2 lithiums to balance my charge of oxygen. Therefore, my formula is Li2O. Li2O. I must balance my reaction. I have 2 lithiums on the right. I need 2 lithiums on the left. But remember, that changes the number of lithium, oxygen, and hydrogen. I have 2 oxygens on the left, but that's okay because I have 2 oxygens on the right. I have 2 hydrogens on the left, I have 2 hydrogens on the right, and I am now balanced. The fifth and final practice problem, Al2S3, that is a binary compound. It's a metal plus a non-metal, which is a very standard ionic compound. And so in the lesson we learned that it's going to break down into its respective elements, which means you just separate it. So it's Al plus S. You want to double check to see if you have any diatomic elements. Don't forget about that. Do I have any diatomic elements? Remember what those 7 were: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Nope, don't have any of those, so this is exactly what I write. I have 2 aluminums on the left, I need 2 aluminums on the right. I have 3 sulfurs on the left, I need 3 sulfurs on the right. I'm now balanced. It has been great working with you for synthesis and decomposition reactions.